Let us look at how you can get well your chemistry paper 1 at A level with flying colors. There we go. Now the easiest way to get a distinction without struggling at A level. Now let's first look at the syllabus. Now the syllabus has 3 branches: physical chemistry. Of course, the first topic called matter contains moral concept, redox reaction, disproportionation reactions. Of course, many students take this to be part of inorganic. Of course, chemistry being that one branch can merge into another, these areas are revisited in inorganic chemistry. They should be actually put on special consideration, and the students have to master them very well because they can't even in the practical. Now there is atomic structure and periodic table, structure and bonding, which includes melting points and shapes. So melting points are included here and shapes. So students, melting points, boiling points are all explained in this part. So you have to put attention on this area because melting points have become a key issue in paper 1. So thermochemistry, these areas try to disturb students very, very much, especially chemical energetics here. So students should put practice on them because the neighbors realize it's their problem, so it keeps bringing what your problem is. Physical equilibrium, chemical equilibrium. Industrial process, I want to put special caution on them, like ammonia, conditions under which you can obtain ammonia on a large scale. Then conditions under which you can obtain sulfur trioxide. These are reversible reactions which are revisited under chemical equilibrium. And they are asked from you to write equations for preparation of these equations for preparation of sulfur trioxide and the conditions. Please put special attention on that and add other industrial processes like manufacture of sodium hydroxide, which is not part of this but could lie under group 7 elements, and also period 3. And sulfuric acid, also put special attention on them because they have become an issue in your papers. Your neighbors know that you don't want to put special attention on them. So ionic equilibrium, chemical kinetics, these areas of electrochemistry. Let's look at another branch here. Now we have inorganic chemistry, which has all this. Now it looks so big with so many equations, but if a student can critically follow, can realize that there are only some special areas which are examined under this group, under this inorganic chemistry, and have actually become troublesome to students. So we are going to analyze them in transitional elements, which areas are actually basically where the eyes are really special for the examiners there. Let's got another branch here. So under organic chemistry, we expect every student at least to be well off in organic chemistry, but the students tend to ignore special reactions such as methanoic acid with the Fehring solution. So don't forget that aldehyde reactions with the Fehrings, with ammoniac silver nitrate. So ensure that you, in your reading, you make special equations and summaries on these other areas of iron 3 chloride with ethanoic acid, with benzoic acid, ammoniac silver nitrate. Yes, then phenol reactions with neutral iron 3 chloride, aminobenzene with bromine water, even phenol with bromine water. So, and also put attention on explaining those reactions. What is nucleophilic addition, nucleophilic substitution, electrophilic substitution? What do they mean? Make sure you can write some short notes on them, and make sure you understand these explanations, especially those that lie under differences in boiling points, differences in acidity in carboxylic acids, and boiling points in amines. So put attention on that. A student should always read up this last part here because in almost every paper, if it's not a detergent, then it's a polymer. Let's go to forward. Now let's look at the examination format here. The paper, of course, it is done in 2 hours and 45 minutes and has 2 sections, section A and section B. a total of 17 questions, and the student is actually going to answer about 15 questions, leaving out only 2 questions. So in section A, there are 9 compulsory questions, so the student answers all. Section B, there are 8 questions. These are set from any part of the syllabus. Any part of the syllabus, we mean any part of the branches. So, but a student must be very tactical if he handle these papers carefully, because some of the papers, like paper 1, are actually marked at a high degree of attention. So a student should actually spot all those areas that the examiner might really want. We are going to put emphasis on how you excel in paper 1 here and what are the issues that the students face in this paper. So the section A carries 46 marks. The marks per number may vary per year. So section B has each question 99 marks. Students are supposed to write in the spaces provided. Some students can misuse their graph papers and end up borrowing other graph papers. Please, you are highly warned that you'll actually just the question, you lose all the marks on the graph paper which you have attached in case graph papers are actually embedded in the question paper. What are the dominant areas that a student should pay attention to? We realize that the paper is actually full of physical chemistry. For some years, you find that the paper is actually full of physical, but you realize that these days, your neighbors actually made it maybe it tries to hold students and make it a bit hard for them to move and excel higher. So the paper is actually, if you analyze, most papers consist of higher numbers in organic than inorganic. But of recent, it is tending to be that more inorganic questions are being put in section B, such as 3 numbers. Of course, some papers have 2 numbers, but we realize that putting 3 numbers in section B is actually an intention to just hold on the students, because most areas in inorganic require equations, and remember, all equations not easy. So organic chemistry makes about 30 to 40%. Of course, inorganic makes 20 to 30, but this is varying, and these days it is tending to be almost the same percentage of organic numbers and inorganic numbers. So don't rule out that the paper will be dominated by organic. But we realize that also, if a student is good in physical and organic, can score between, if it's very, very good with almost no errors, can score between 75 to 85%. In case they fixed the paper to have 3 questions of inorganic in section B, so having physical well and organic well can yield you between 75 to 80%, with one area inorganic lacking in your answering. So if you are good in physical and organic, you are set to go. You can even get a D section 1 or a D2, but D1 can be actually a tug of war. You need a supplement for inorganic. Now, being good in organic and organic makes you to score between organic and inorganic if you are bad in physical and you are very, very good. So if you are not very good in the 2, inorganic and organic, you are highly going to score below 50. You'll be in 40s. So if you are very good in organic and very good in inorganic, you are highly not going to exceed 65%. So it shows you that when you leave out physical, actually you are in danger. What if you are good in physical and inorganic, you score the same range, about 75 to about between 70 to about 80%. 70 to 80%. The maximum score, if provided you are very good, that is physical and inorganic. Provided you are very good, and you are going to lose some marks, like about, of course, we are counting a loss of about 2 numbers in section B for inorganic and 2 numbers in section A for organic chemistry. I mean 2 numbers organic in B and in A for a loss. So you see that the questions per section may vary slightly year per year. You can't rule out that there will be 2 organic and 2 inorganic. They can actually dominate a paper with physical. We are going to see some sample papers. Like here in section A has about 3 to 4 physical. That is normally analysis of a number of papers, and 2 for inorganic. They don't normally exceed 2, but they can go even below 2 and become only 1. So also 2 to 3 for organic chemistry, then section B 3 to 4 for physical. And 1 year there was 5 questions in physical, but that's a rare case. Then 2 to 3 for organic and 2 to 3 for inorganic. And most of these papers these days are having 3 numbers for inorganic, so there is no you can escape inorganic in section B. So let's look at some sample papers. We'll go and open them. Of course, we shall look at some at the end here. That in 2023, there were 4 questions in section F for physical. So if you are bad off in inorganic, the inorganic areas that we are going to show you here, we are going to show you the inorganic areas that actually make students fail, yet they are actually not even hard, like qualitative analysis. Can that be hard for a student? Like explaining melting points. Does that have equations? So that means the student can as well clear the inorganic questions in section A, which you might not need to read the crude equations found in group 4, found in transition elements, but actually master redox reaction, master qualitative analysis, master actual melting points, master periodic properties, and simple explanations in the introductory part of transition elements, as we're going to see. Which inorganic areas were in this paper? There was qualitative analysis in section A, obvious case, melting points in section A, obvious case. Then there was group 2 in section B, and some group 4, somewhere, and the aluminium in group 4 in section B. So a student could as well handle physical well, handle organic well, then have 1 question in section B. Of course, these qualitative and melting points were massed in section A. Now looking at UNEB 2022 had 5 questions in physical. Physical, I mean even the redox areas, all shapes are all here. So we saw qualitative analysis again repeated in 2022, then structure and shapes. So shapes were here, also back here. So shapes are very, very key, and they are part of physical chemistry. Then we had 1 inorganic number, which was directly from inorganic. Group 4 ligand exchange reactions, we mean the introductory part of transition elements, and also qualitative analysis, which contains addition of concentrated hydrochloric acid to cobalt 2 salt and addition of concentrated hydrochloric acid to copper 2 salt. Remember to also read about addition of concentrated HCl to lead 2 ions, lead 2 nitrate, lead 2 oxide. Those are special cases which can be set for in section A. Let's look at another here. 2020 had 4 questions of physical in section A, 3 for organic, then 2 for inorganic. Now that was actually a fairer paper. Of course, the areas are actually qualitative analysis. Redox was there. Then shapes were there from physical. Group 4 could have been section B, I think. Then we shall look at that paper. Then special reactions of organic chemistry, we refer to addition of like Feherring solution to ethanol, Feherrings to methanoic acid. Those are the questions that we look about. Then the iodoform reactions, the equations, students tend to ignore them very, very much. UNEB 2019 had 5 questions in physical, which is a rare case. Then 2 in organic and 2 for organic. Then also for section B, physical. So the whole paper was dominated by physical. And you realize that such a case, students are always excelling highly in case the paper has 2 questions of inorganic in section B. But now UNEB 2020 had so many for inorganic, so it was a bit hard for students. So there was qualitative analysis, redox reactions. Of course, I've ignored the organic and physical, knowing that those that are directly heavy topics in organic and physical, I've actually held them, knowing that students should really put energy on physical and organic for better excellence of marks. Let's now look at what I'm calling the checklist, the common topics the common areas that a student should do. A must read for students in paper 1. Let's go. A student should have done practice on all the organic chemistry. Reason: we cannot predict where a synthesis might require a reaction from carboxylic acid. Then also must have read polymers and detergents. So must have listed this because this can appear as a section A or section B. So and you can't lose those marks. These are simple areas. Organic is quite obvious for students. Then also a student should have done good work in physical. Then having done all this for physical and organic good in calculations, reason we can't predict anything from physical can appear in section A. So ensure that you have done enough practice in the physical and organic. We said upon that effect, if you are good in physical and organic without inorganic, you can score between 75 marks, maximum to about 85, even 90 you can reach depending on which areas have been examined in inorganic chemistry. So apart from physical, some of the additional areas in physical and inorganic where students should put attention are qualitative analysis. Students must actually practice equations like addition of sodium hydroxide to cobalt ions, must know the equations for oxidation when left standing also. So must look at addition of the reagent, dropwise, and in excess the required equations and understanding what happens. Redox reactions are also ignored. Disproportionation reaction like disproportionation of manganate 6 ions in acidic medium or in neutral medium. Like if a question said the carbon dioxide was bubbled through a solution of potassium manganate 6. So those are what we are calling disproportionation. There are about 2 special disproportionation reactions. Disproportionation of copper 1 oxide in dilute sulfuric acid. Copper 1 oxide in dilute sulfuric acid. Somebody should go and put attention on that in dilute sulfuric acid. Also, disproportionation of course occurs in many things like halogens, but we are emphasizing that when you are entering the paper, ensure these are at your fingertips. Then ensure that redox reactions are at your fingertips. Then some other additional reactions under redox and disproportionation. Please put attention to them. Then we have said there are some special reactions in organic chemistry where students have not put attention. Please endeavor you put attention to them, like ammoniacal silver nitrate solution, iodine solution, sodium hydroxide, benzoic acid, iron 3 chloride, Fehring solution. I've already emphasized those, and many others that I have not included in this part due to space and time. So students don't put attention to them. They can appear in section A or in section B. They can get you off guard. So ensure that you have read them. Then these are for paper 1 emphasis. So in the transition elements, go and read the introduction, specifically which contains oxidation states, because we can ask you why does manganese have variable oxidation states, or we can ask you try the oxidation states. We can ask you to name complexes. We can ask you to explain why something is a catalyst. So why melting, why high melting and boiling points, writing isomers. Please endeavor that you visit those areas, especially ionization isomers of this compound. Very, very important. Why are compounds colored? These are areas which catch students unaware in actually inorganic chemistry, like ligand exchange reactions involving concentrated hydrochloric acid on copper salts and cobalt salts. Lead salts I've just added it here because also they can ask you if you added concentrated hydrochloric acid to lead salts. Special reactions in inorganic chemistry such as visit the area containing manganate 6 ions and read it. Preparation reactions. Visit an area containing chromate ions. Visit an area containing dichromate ions, and there behave in acidic medium and an alkaline medium. Of course, now number 6 about extractions. These are common in section B, but you can't rule out them in section A. So these are very, very common questions here in section B of paper 1. So you can read them. If you are have some time. If you don't have some time, emphasize these simple areas. Then cationic hydrolysis. This question last came in 2017 about the addition of magnesium ribbon to a solution of, say, aluminium ions or a solution of chromium ions. So this area very, very key. It can check you up and catch you unaware. Paper 1 is full of a lot of this group chemistry. If they don't set, because we've said if it's not group chemistry, then the areas are rotating on qualitative analysis, hydrolysis of highly charged cations, melting points here, periodic properties. So you can as well, this if it disturbs you, then emphasize on these other areas of inorganic chemistry. Of course, their reactions are set, but of course, we are going to emphasize to which reactions are there. Shapes of molecules is also highly sensitive, as we've said. So under inorganic chemistry, if you can't read all reactions, at least read these. Sodium hydroxide reactions and water reactions. Those I'm calling them, I have not included the water here. Water with hydrides and chlorides. Then I've also not included sulfuric acid with hydrides. Also keep that one also, sulfuric acid with hydrides. So group 7, highly sensitive. This hydrolysis of salts, common area, but has been set less, like it last came in 2012 in paper 2. But understanding it, why some solutions are acidic, is why ammonium chloride is acidic, is actually good for you. So special explanation. So as you read your notes, also put attention to explaining certain processes, like explaining why glucose in solution, the solution boils at a higher boiling point than when you have pure water. So thank you very, very much. Those are so far the common things that you ought to master there. Now we want to look at some of the papers and some of the mistakes in this paper. Now let us look at some sample papers here. Here we have with us UNEB 2019. Let us go through it and see what was said here and how did we handle that. Now, in section A, of course, we said that a student should be good in physical chemistry and organic. You might not put a lot of emphasis on this physical number, but we are looking at some of the most dangerous areas, such as this number 2. Of course, the terrifying questions are always in inorganic chemistry and some areas of physical where students are not aware that they are actually physical questions, like this number here. This is actually an inorganic question for qualitative analysis, whereas this one is a redox question in physical. So you see that this paper one, they can combine physical and the inorganic, or physical with the organic, or organic with inorganic. So such a question will be a bit a problem to students. And scan through this is physical, which of course a student should be well off. Physical also is here. So those are obvious areas. This is organic chemistry. We say the student to do well in paper 1 should have had the all physical and all the organic, at least 90%. Now looking down into number 6, we can see that this is actually inorganic chemistry, but basically in the area here, it's full of this section here. One area is a preparation of manganate 6 So in reading disproportionation of manganate 6, at least a student should read about its preparation. So the questions of manganate 6 are always rotating around there. Preparation, then disproportionation or the redox reaction as in part C here. So part B is preparation. Part C is actually the redox reaction of manganate 6 with chlorine gas. Number 7 is a physical number. 8 is organic, so those are obvious. We expect every student. Number 9 is actually inorganic question. That's why we have said that a student should put emphasis on water and sodium hydroxide reactions. So mostly your paper 1 consists of those key reactions, sodium hydroxide and water. So put emphasis there. If you don't have enough time to read the whole of the inorganic chemistry, we said put emphasis on reactions with water and sodium hydroxide, plus a few other reactions that we emphasized. So these are some of the properties of this group, fluorine as a member of group 7. So number 10 is organic, an obvious question. Number 11, physical question. Number 12, that is inorganic question. So a student can as well dodge this if you are aware of in physical and organic. This is organic, this is physical, this is inorganic, and basically there is a ligand exchange reaction here. Then there is qualitative analysis on these two parts here. So you see that a student who is good in, we said those areas, if you can't read up to the whole cobalt chemistry, then make sure you have read its qualitative analysis and the introductory part to transition elements consisting of ligand exchange reactions with concentrated hydrochloric acid. Of course, there are a few reactions in cobalt. Now, this area is in physical chemistry, but students mistake it under inorganic. But of course, we said be good in physical, and here structures affect students because of the shapes. The bonds don't touch, and the electrons are located in wrong places. So special attention should be put to that. This is physical and obvious question. So that's basically 2019. You can also dive into UNEB 2020 to look at how it moves here. So in 2020, number 1 was actually basically physical. Number 2, organic. Those are obvious areas. This is, of course, a physical question. So these shapes, actually, I think you've observed that these shapes are actually very, very common areas because of the fact that the students know the shapes, but they don't draw them well. They put bonds in the wrong place. So looking down into physical is also organic. Those are obvious areas. This is physical plus some part of inorganic here. And see that is actually a mixture. Physical under oxidation state, that's redox area in physical. This is physical. So a student who is good in physical chemistry, you're actually set to go. So this is one of the inorganic areas we emphasized in our parts there, that but this is, of course, an obvious area, acidity, which is also found in physical. This is number 10, is actually organic. This is the area we said special reactions in organic chemistry. Plus for heading, students have not paid attention to those equations. Please watch about those equations. They can be put in section A, where you cannot escape. This is qualitative analysis. I think you can see. So qualitative analysis there. This is physical, quite obvious. This is organic chemistry. This is inorganic chemistry. So you can see, that's your inorganic chemistry. This is organic. This paper is full of inorganic areas. That's why most students crashed. That's physical. This is inorganic. Actually, these are about 4 questions in inorganic and 2 in physical, and about 2 in organic chemistry. Let us look at UNEB 2022. In 2022, what happened there? In 2022, let's look at what happened. This is physical. Again, shapes are back. So you see that shapes is another issue here. So keep attention on shapes where you put bonds. Bonds should touch electrons in right places, considering lone pair repulsions and all those repulsions. This is organic, quite obvious. This is physical, but keep attention on how you make definitions. That's another area for students. This is actually qualitative analysis of chromium ions, the confirmatory tests. These are areas where students don't pay attention, they don't read their practical books, so they end up crashing in such questions. So that is physical chemistry, physical chemistry. This is now also physical chemistry under industrial processes in of course under chemical equilibrium. It's physical, this is organic. So a student who is good, we see that there is only almost 1 inorganic question here. So be good in physical and organic. You'll be about 75%. So this is your industrial processes in industrial application of chemical equilibrium. This is mixed with the inorganic. So this is organic. I mean that is physical, but of course having some inorganic in it a little bit. And this is physical. This is again that is inorganic question starting with the empirical formula. So this is organic. This is physical. This is inorganic. You can see that there are quite a number of inorganic questions. So if a paper has like 3 inorganic questions, the students can find a problem in section B because some reactions they don't remember. And of course, we've emphasized the key questions in physical and in inorganic areas where you might not pay attention to all, but special attention to the ones we've emphasized before. So looking at 2023, maybe this being a current paper, and look at it. Part 1, number 1 is physical, number 2 is organic chemistry applied, that's soap. So students should watch a lot on soap and polymers. This is of course mixed in some physical and some, of course, that's physical chemistry. This number 4 is a special area of qualitative analysis where students have not paid special attention to some of those simple things. So this is organic, this is physical. Melting points have started to be an issue, so students should make summaries. This is physical chemistry. This one is organic. This is inorganic. This paper had also 3 questions of inorganic in section B. That's why it crashed most of the students, because remember there was qualitative analysis, students ignore those areas, and there is another inorganic number here. So another inorganic here. So if there are 3 inorganic questions, there is no way of escaping. You must at least have something there. Progress. Now let us look at the mistakes that candidates commit when handling paper 1. Now the first common mistake is writing wrong chemical symbols. Like writing L like a 1 instead of a bent or curved L somehow. Then writing the small letters in front of the capital letter without minding on whether it's halfway or it's not halfway. The letter should be actually halfway, so that will be a correct symbol. Now, most students at A level put numbers between the letters instead of bringing it slightly below so that the line dividing it divides the number into two. So keenness should be put on the chemical symbols and chemical formula. For example, when students are writing mechanisms, organic compounds, they're always putting numbers between letters. I don't know why, but that should be highly warned and you should make sure you improve on that. Then wrong chemical names, especially for reagents, like spelling iodine. When you are starting a reagent, make sure it starts with a capital letter, like this capital I. Now, like if you are putting Roman numerals between the name of a chemical reagent or chemical substance, ensure that you use the correct Roman numeral like this without the dots on the I. Then some students are always defining wrongly, misfiring definitions. So you should improve on the definitions. For example, in 2022, they requested the students to define bond energy and some of them were defining it wrongly. Also, wrong chemical structures. Most students have a problem in drawing benzene, but even mine, though it's not accurate but fair, ensure that the circle inside is fairly large, not this small one here. And other chemical structures, of course, draw them rightly. Then arrows and bonds should either touch atoms or should reach atoms. Like here, there is a gap here, so it will be penalized here. So make sure that the bonds are actually touching the atoms. Now let's look at this benzene mechanism here. Where should you put, see this area? You should open around where the electrophile has actually been bonded to. Then finally finish up the mechanism like that. Now if you use bonds here, then the positive charge should either be out or inside, but the bond bringing back the electrons should not be at the corner here, should just be in the middle but entering a little inside here. That should be the best mechanism. So other complaints are on where students use wrong chemical formula. If a formula has given you a mass of a substance or mass of a gas, then why use the number of moles here? So this would be a wrong formula and this would be a correct formula, maybe receiving even up to half a mark. Grammars law, students use wrong formulas. If the question has time, then make sure you have a formula, use a formula involving time. So keep attention on those things there. Also another alarming area is where students actually misfire the reagents, and like if you are distinguishing between a ketone and an aldehyde, even though one has a methyl group, we expect you to use the correct reagents such as Feherings. So keep attention on how you distinguish which reagent should be proper there. Okay, there are so many other things, but let's pause there for the interest of time and to avoid making the video so long. Thank you for following up. Keep those things at your attention for success. Bye.
Recording stopped.